Hello and welcome back for the last lesson of chapter 9. This is where we're going to put it all together for hypothesis testing. And I mentioned at the end of lesson 9.4 that hypothesis testing has 6 steps, and we're going to put them all together now. So the first step is to state the hypothesis. So you can see here, for example 1, I stated the hypothesis. The null hypothesis is that the mean is equal to 10, and then the alternative hypothesis is that the mean is less than 10. That's what we're trying to argue. State the level of significance. That's our alpha. Okay. And then we're going to learn how to calculate the p-value, which is the probability of this weird outcome happening if the H0 is true. We're going to draw a graph. We're going to make our decision to reject or do not reject, and then we're going to write a conclusion. So let's start with some of the little pieces. Here is our H0 and H1 in example 1. Assume the p-value is 0.0935. What type of test is this? So this is a left tail test of means. And then our picture, because it's just a left tail, it's just over here. And then our p-value is always written here. Example 2, we have our H0 where the mean is less than or equal to 1, and the HA where the mean is greater than 1. And this would really just be an equal to. Assume the p-value is 0.1243. What type of test is this? This is a greater than, so it's a right-tailed test of means. And we're going to draw a picture here, and the p-value is drawn right here. So that's how we draw the picture. Example 3, H0 is 0.5, HA is not equal to 0.5, so it's a two-tailed test. So we're going to have a two-tailed test. Assume the p-value is 0.2564. What type of test is this? It's a not equal to, so it's a two-tailed. And then to draw our p-value, we have to take and divide that by 2, because half is on the left and half is on the right. Now, when we go to make our conclusion, we're going to use all of the p-value all together. Okay, let's look at it. Example 4. So it says Jeffrey, as an 8-year-old, established a mean time of 16.43 seconds for swimming the 25-yard freestyle with a standard deviation of 0.8. His dad, Frank, thought that Jeffrey could swim the 25-yard freestyle faster using goggles. Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 swims. For the 15 swims, Jeffrey's mean time was 16 seconds. Frank thought that the goggles helped Jeffrey to swim faster than the 16.43 seconds. Conduct a hypothesis test using a preset alpha at 0.05. Assume that the swim times for the 25-yard freestyle are normal. So let's just jump in so you can see the 6 steps. So our hypothesis statement is H0, the mean is equal to 16.43. We're proposing it's less than 16.43 after he wears the goggles. The level of significance is 0.05. And then to calculate the p-value, because we know the standard deviation, so we're going to use the normal curve. Okay, and so we state that right here. We're going to use the normal curve because we know the standard deviation. So our established mean is 16.43. Here's our standard error by taking the standard deviation and dividing by the square root of n. So to calculate the p-value, when we know the standard deviation, so in Desmos, you're going to want to write this down, but I link it in the Desmos link for 9.5 as well. But in Desmos, you're going to use just the normal distribution with the CDF of the mean and then the standard deviation, the square root of n. So you're going to use that. So I'm going to show you how we calculate this p-value right here, 0.0187. So in the Desmos link, you're going to do open the folder. So the example 4, we're going to use the normal distribution. And I put in the established mean and the established standard deviation of 0.8. And then we're proposing that it's less than 16 seconds. So I'm going to say, what is the probability of it being less than 16 seconds with these parameters? And that is 0.01868 or 0.0187. And if you click on the graph and hit the magnifying glass, you can see it drawn here. It's out here. It's pretty small. Okay. So if you go back to my paper here and flip the page, we can see that our assumption is 16.43 seconds and our p-value is 0.0187. And we think it's less than, so it's a strictly left-tailed. So the p-value is here. And there's the established mean. Okay. And then we're going to make a decision. So we're going to compare alpha and the p-value. I always choose to put my p-value on the left, which is 0.0187, and my alpha on the right. Because if my p-value is less than alpha, which it is, then we do reject H0. And you can see that because since we reject H0, since the p-value is less than alpha, and we reject H0, it says we do not think Jeffrey's swim, the 25-yard, is less than 16.43 seconds, but faster with the new goggles. So the conclusion we say at the 5% significance level, we conclude that Jeffrey swims faster using the new goggles. The sample data show there is sufficient evidence that Jeffrey's mean time to swim the 25-yard freestyle is less than 16.43 seconds. And that's because the p-value is less than 0.05. So we do reject H0 and we do think that he does swim faster. I'll take a minute and get all that jotted down. So let's look at example 5. We're going to do several of these together on our own. So example 5 says the mean throwing distance for a football for Marco, a high school freshman quarterback, is 40 yards with a standard deviation of 2 yards. Okay, so they're giving us the mean and standard deviation. The team coach tells Marco to adjust his grip to get more distance. The coach records the distances for 20 throws. For the 20 throws, Marco's mean distance was 45 yards. The coach thought the different grips helped Marco throw farther than 40 yards. Conduct a hypothesis test using a preset alpha at 0.05. Assume the throw distances for footballs are normal. First, determine what type of test this is. Set up the hypothesis test. Find the p-value, sketch the graph, and state your conclusion. So you can see that I've set up all 6 of your steps for you here that you're going to fill in. So this is how your paper should look as you're doing the hypothesis test. So our hypothesis is H0 and HA. H0, because we're talking about the mean, is going to be our symbol mu. And the H0 is always an equal to, and they think typically he throws at 40 yards. But the coach says, hey, if you change your grip, we think you can actually throw it further, because it says here, throw farther than 40. So we're proposing with the new grip, he's going to throw it further than 40. Notice that the symbol is the same. The number that you're comparing is the same. It's just the inequality changes from H0 to HA. So our level of significance is alpha equals 0.05, and then find the p-value. Okay, so we need to check the p-value. Let's just go ahead and draw what our graph is going to look like. It's a greater than, so it's going to be pointing to the right. So we're going to draw over here. And his sample mean, we're going to need these information for a Desmos. So N is going to be, there were 20 throws, and the sample mean was actually 45 yards. Okay, the population mean that we think is true is the mu0 is 40, and the standard deviation is 2. So let's go to Desmos. I'm going to show you how we calculate this. I'm going to click on the folder here. So again, because we know the population, standard deviation, we can just use a normal curve. And the mean is 40, the standard deviation is 2 divided by the square root of n. And we're proposing, we want to know what is the probability that he threw 45 yards or further. His sample average of those 20 throws was 45. And it says 2.5447, which seems high, but notice this right here, times 10 to the negative 29. It's actually very, 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 very small. So, and I'm just going to make a note here for you. P-value so small, you can write. You can just put the symbol less than 0.0001. And then that tells the viewer that it's so small, you can't even write it out. Okay. So let's go back to our paper here. And it is, okay. So our p-value is less than 0.0001. So, I mean, it's so small that you can just write this. And you know it's going to be less than the 0.05, the alpha. So we do reject H0. So basically, I just wrote everything we need for the decision is all right here, comparing the p-value to the alpha, and then we do reject H0. And so our conclusion says, because we rejected H0, we can say there is sufficient evidence to conclude the new grip helps Marco throw farther than 40 yards. Okay, so this is what it looks like. All 6 steps. Okay. I'm going to show you another one here that's all worked out. So all the data, everything that you need is to see how I calculated all this is in Desmos and under a folder number 6. So statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks the mean score is higher than 65. He samples 10 statistics students and obtains their scores. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So step 1, we have our H0 is mu equals 65, and HA is, we think it's higher. He said higher, I'm going to circle that. So that's why we think it's greater than 65. They don't tell us, so we're going to assume we're going to use a 5% level of significance. So alpha equals 0.05. And step 3 is we can calculate our test statistic. Okay, this is our test statistic. But the cool thing is we can actually just use Desmos program. So use Desmos program for means one sample. Okay, so let's go there, and we are proving that the p-value is right here, 0.0396. Okay, so I'm going to show you where you can find that in Desmos. So example 6, it shows you all right here. So to do that, you're going to need to get the sample mean. So I put my data in a table because we had raw data. I did the mean of X1 and the standard deviation so that we have the sample standard deviation. And also notice, because we do not know the standard deviation from the population, we're just going to use our program from Desmos. So I went to my means for one sample, and right here is what it looks like. And it says only use this when the population standard deviation is unknown. So that's this case. So we sampled 10 statistics students. The sample mean from the test was 67 is what we came up with. Right here, you can see 67. And the sample standard deviation was 3.1972. 3.1972. Oops. Okay. And then we're proposing, they thought it was really 65, but we think it's actually higher. And so because it's a right-tailed, we're going to go down and notice all the choices. There's a confidence interval, which we did in chapter 8. And then the p-value, we're going to do this right here. We are doing a greater than, so we're choosing this one right here. And then the p-value is 0.0396, just like we saw on our paper. Oops, okay. So 0.0396. So we're going to draw that on the graph. It's a greater than, so it's a right-tailed, and it's 0.0396. And step 5 is going to compare the p-value to the alpha. So p-value is definitely less than 0.05. So we do reject H0. So in other words, you believe that the average test score is more than 65. So at a 5% level of significance, the sample data shows sufficient evidence that the mean average test score is more than 65, just as the math instructor thinks. Okay. So let's try another one where we have our own data. So example 7 says, it is believed that a stock price for a particular company will grow at a rate of $5 per week. An investor believes the stock won't grow as quickly. The change in stock price is recorded for 10 weeks and as follows. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Perform a hypothesis test using 5% level of significance. And we're going to state all of our steps. And now notice I did not label them all out. So we're going to have to do that. So our step 1 is H0 and HA. And we're talking about the mean price or average price. So it's the mean we believe is 5. And it says an investor believes the stock won't grow as quickly. So right now we think it's growing 5 per week, but won't grow as quickly means that we think it's less than 5. Step 2 is our alpha is 0.05 from the 5%. And step 3 is we're going to go and find our p-value. Okay, so we need to find our sample mean from Desmos and our sample standard deviation. And it says that they collected data for 10 weeks. And because it's a less than, this is going to be our step 4 is our graph. that means that our p-value is going to be over here. And then our step 5 is going to be comparing our p-value to alpha, which is 0.05. And then we're going to have our conclusion in step 6. Okay, so let's go and take all of this information to Desmos so you can see how we will complete this. So this is example 7. So I entered the data, and because the standard deviation is unknown, we can go ahead and use our Desmos program. So I found the sample mean is 2.6. The sample standard deviation is 1.8379 rounded. And I wrote down here for you everything that I entered. To get the p-value. Okay, and so I'm going to show you how I did that. So I just went here and I entered the sample was 10 and the sample mean was 2.6. The sample standard deviation was 1.8379. And from history, we think they were averaging growth of $5 per week. And because it's a less than, we're going to click on the less than, and there's our p-value. So our p-value is right here, so it's 0.0013. So back to our paper for that. So I just wrote down for myself the sample mean and standard deviation, so I would have them in front of me when I go to my other Desmos screen. There's my p-value, which is right here. It's definitely less than 0.05, so we do reject H0. So in a conclusion, there is sufficient evidence to support the claim that the stock is not growing at $5 per week. Not growing at $5 per week. So there's our 6 steps. So let's look at example 8. In 1955, Life magazine reported that 25-year-old mother of 3 worked on average an 80-hour week. Recently, many groups have been studying whether or not the women's movement has in fact resulted in an increase in the average work week for women, combining employment and at-home work. Suppose a study was done to determine if the mean work week has increased. 81 women were surveyed with the following results. The sample mean was 83, the sample standard deviation was 10. Does it appear that the mean work week has increased for women? That's the question. Okay, so our hypothesis statements. So they originally proposed that the mean work week was equal to 80, but since then they feel that it's increased. So the mean is greater than 80 is what they're proposing. And the alpha is at 0.05 testing level. And number 3 is we're going to calculate the p-value using the information we're going to enter into Desmos. So that means N is, there were 81 women, they told us. The sample mean was 83, and the sample standard deviation is 10. So step 4 is going to be a p-value graph, which is greater than here. And step 5 is we're going to actually go and find the p-value and then compare it to alpha, which is 0.05. And then, of course, our conclusion. So let's go enter in our information into Desmos. I'm going to show you how I'm going to do that. This is example 8. And so I'm going to enter all that in, and it looks like we get a p-value right here of 0.00128. And so once we can use these computer programs in Desmos, it just makes it so easy where we don't really need to do too much in Desmos. Just go to the program and enter our information. So our mean was 80, or our sample size was 81. The mean was 83. S is 10. And what we think is true is 80 about the population. And so there is, we're going to go to a greater than is what we're testing. And I'm going to turn on the picture, and there it is. A greater than, and my p-value is 0.00423 when I round it. You can see it right here in the graph as well where my mouse is. What did let's see, 80. Let's see, I think I just typed the wrong thing. And it's a greater than is 0.00423. 0.00423. Okay, so let's go back and share our paper. Definitely be typing these in on your own Desmos, just to make sure that you're validating the same answers that I'm getting. So with my N, my sample mean, my sample standard deviation, I got a p-value of 0.0043, which is definitely less than. So we do reject H0. So there is sufficient evidence to support the claim that the true average number of hours a woman works is more than 80. Because we did reject H0. Okay. Let's look at example 9. Okay. Example 9 says, a teacher believes that 85% of students in the class will want to go on a field trip to the local zoo. She performs a hypothesis test to determine if the percentage is the same or different from 85%. The teacher samples 50 students and 39 reply that they would want to go to the zoo. For the hypothesis test, use a 1% level of significance. First, determine what type of test this is, and then all steps. Okay. So one thing we have to take note is that we're talking about percentages. So this is about proportions. And our H0 and our H1, it says the teacher believes that 85% want to go on the trip. So that P now is the symbol we're using for proportions is 0.85. So she's testing to see if it's the same or different. So this is really going to be a not equal to 0.85. She's not sure if it really is. That's what she believes is true from maybe past data. This time our alpha we said is 0.01 from this 1% level of significance. And we are definitely going to find a p-value. We're going to use Desmos for proportions. And so we're going to need our p hat, which is x divided by n. If they don't give you a sample percentage, you have to calculate it. That's calculated from 39 said, yes, they want to go to zoo out of 50. So 39 out of 50 students gives us a sample p hat of 0.78. And then obviously n is equal to 50. And so we're going to get our p-value and compare that to alpha 0.01. Okay, and in step 4, it's a not equal to here from our step 1. So that means we're going to have a two-tailed graphs here. And our p-value is going to be split. But our p-value altogether is what we compare to 0.01 to make our decision. So let's go. I'm going to show you what it will look like for proportions in Desmos. And it's this one here that we use in confidence intervals. It's for proportions. And so we're going to enter our sample size was 50. And our p hat, our sample proportion is 0.78. And we thought from our history there that it's 0.85 wanted to go, but it looks like a little bit less than what we thought want to go to the zoo. And so we are proposing a not equal to, so let's click on that one, the not equal to. And so our p-value is 0.1656. 1656. Which is greater than 0.01. So we do not reject H0. So there is not sufficient evidence to say that the percentage of students who want to go to the zoo is any different than 85%. The sample was a little bit less than 85%, but it's not enough to say that there's a significant difference. Again, make sure that you have all 6 steps when you're writing these out. It's very important. Marketers believe that 92% of adults in the US own a cell phone. A cell phone manufacturer believes that that number is actually lower. 200 American adults are surveyed, of which 174 report having cell phones. Use a 5% level of significance and complete all 6 steps. And we're not going to worry about identifying the type 1 and type 2 errors for these. We just want to practice our hypothesis test. So we're proposing that is equal to 0.92. And the phone manufacturer believes that actually less than that own a cell phone. So it's a less than. So our picture is going to be a less than over here. Okay, and we're going to compare. It says alpha is 0.05. And step 3 is our p-value calculation. And so we're going to need our n is 200 and our p hat is X divided by N, and they said 174 out of the 200 is 0.87, which is lower than 0.92, but we're going to find out if it's statistically lower. So N has 200. Whoops, this is actually a 9.2, and this is the 8.7. And we are less than, and so our p-value is 0.00457. And let's just make sure that we have that here in the cell phone. Yes. Oh. And let's just go back to the paper so we can write this out. So our paper is compared to alpha is 0.05. It's definitely less than, so we do reject H0. So there is sufficient evidence to support the claim that fewer than 92% of adults in the US own a cell phone. 92% is pretty high, so I guess that doesn't surprise me too much. There's our p-value, and that is example 10. And our last example, it says a poll done for Newsweek found that 13% of Americans have seen or sensed the presence of an angel. A contingent doubts that the percent is really that high. It conducts its own survey. Out of 76 Americans surveyed, only 2 had seen or sensed the presence of an angel. As a result of the contingent survey, would you agree with the Newsweek poll? In complete sentences, also give 3 reasons why the 2 polls might give different results. Okay, so they didn't say to formally give a hypothesis test, but it's kind of good to kind of write them out for practice, and then also it will kind of help us answer this question. So they think that P is equal to 0.13. The contingent is proposing that it's less than 0.13, so it's going to be a left-tailed test. And they didn't give us an alpha, so we're going to just use 0.05. And then we're going to calculate our p-value here, where the p hat is x over n, and x is 2 out of the 76, which is 0.02632, which is definitely quite a bit less than the 13%. So let's go ahead and look at our p-value compared to alpha here. And we'll go to Desmos to do that. And then we're going to see what we agree with, Newsweek or not. Okay, so we're going to enter all this into the proportions one. I thought it was 13%. Wait. 6. Okay. And so we think it's less than. So I'm going to draw the graph for this. So our p-value is pretty small. It's 0.00359 or 0.0036. Okay, so pretty small, 0.00. Definitely less than alpha. So we definitely do reject H0. So it says, as a result of the contingents, the survey casts doubt and conducts its own survey. Okay. So as a result of the contingent survey, would you agree with the Newsweek poll? So I would disagree with the Newsweek poll. However, I would be a little skeptical of the contingent survey. So I'm disagreeing with the 13% because we definitely do reject A0. The p-value it's pretty small. However, the 3 reasons why the 2 polls might give different results. So n equal to 76. So let's just do n PQ and see what we get. So 76, and we have to use P is 0.13 and 0.87 here. And that comes out to be 8.59, which is less than 10. So we cannot say it's normally distributed because we didn't meet that criteria. So that's one issue we have. We would need a bigger sample size really to agree with the contingent. Another thing would be contingent did their own survey. So, I mean, if I went and asked the question that I was looking for a certain answer, I might ask the question in a particular way. So that's an issue, did their own survey. And then the types of readers that read, the types of readers that follow Newsweek versus the people in the contingent might have different opinions. The readers or the subjects, whatever we want to call them, may have some kind of a bias that is for or against angels, right? Anyway, so there might be like a little bit of an inherent bias there. So we always have to kind of think about that when we are looking at hypothesis testing. So that concludes chapter 9. There's a lot in this lesson of 9.5. Please reach out if you have any questions. I would love to help and answer those. Have a blessed day.